So you're ready to start building an app? In this video, we're going to identify what are the requirements of our application, some kind of a UI, like what do we want the UI to be, and let's start thinking about the tech stack and how we want to design and build it. The app that I have in mind is a messaging app. I'm tentatively titling it Inbox. The idea is you can view your messages. You can send a message to someone else. You can have them take a look at the message. They can respond and stuff like that. I also have some folder-based categorization of messages that you would see in a typical email application. So that's the app that we want to build. And I want to build this app in such a way that it is very scalable and it's very available, right? That's the goal. A bit of a disclaimer, though, we're not going to be building an email application here, right? We're not going to be doing SMTP and, having the ability to send emails to other email IDs. This is all going to be in-app, right? You have a bunch of users using this app, and they can send messages and interact with each other using this messaging application. That's the goal, all right? So let's identify some of the top feature requirements that we have, and we're going to break it down into what the UI is going to be. This is how I typically tend to approach a app design, like how I would build an application, kind of identify the top level functional and non-functional requirements. Once I have that, then I can kind of go into a little more detail about how those requirements play with each other. And then there comes a time when you're going to have to build the UI. Like what would the app look like, right? I definitely recommend people building the app to start from the user experience, because that's what drives everything else. And we're going to be using that approach over here. In the real world, you typically have the user experience and the user requirements handed to you as, especially as a backend developer, you're given the requirements. But there are a lot of opportunities where you have the ability to influence that as well. So having this skill set definitely helps. So we're going to start from there. You're going to start having listing the high level functional requirements. So let's start there, right? First of all, I want to be able to compose a message and send it to someone, okay? I should also be able to view my messages. And view has an interesting implication in terms of the folder structure, some kind of a folder / label organization, all right? So this might include an inbox folder, a sent items folder, and maybe some other user folder classification, okay? And I should also be able to reply all to an email. I should be able to view an email, and that's another thing that we need to add. View a specific message. View a single message. All right. You should be able to view a message, and then you should be able to respond to that message by either using a reply or a reply all. Okay. So these are some high-level functionality that I want to build in. I'm going to try doing attachments. I'm not sure if time permits. I have kind of time boxed this, so I don't want this to go on forever, the series to go on forever. So if time permits, I'm going to have attachments built into it as well. But these are the goals. There are a bunch of other requirements that kind of this implies, the non-functional requirements that we need to target, all right? So let's take a look at that. I'm going to have a bunch of non-functional requirements, which is what is going to make this challenging, all right? We want to be able to build an highly available system. I'm going to have a high scalability. Okay, I want the app to be able to scale for a large number of users, right? So let's say this app becomes super popular, right? It's on the top page of Reddit or the New York Times or whatever, right? Even if that's the case, you need to be confident that the app can scale. You need to build the app in such a way that you're confident that it can scale from thousands of users to millions of users or even more. So that's going to be the goal. We also have security as a requirement because this requires authentication, right? People need to log in to be able to see their messages. We don't want everybody to see everybody's messages, obviously. So you have authentication and authorization. Okay, so these are the goals. Now let's chalk out some basic user experience for this app. But I'm going to write a few kind of wireframe sketches to indicate what are the main pages in the app, and then we can go from there. The first page is, of course, the login page. We want users to be able to log in. And for the login page, just like with my previous Code With Me series, I'm not going to be building a full-blown user and password management system because that's going to take a while, okay? I'm just going to use OAuth for this, OAuth support. I'm going to GitHub OAuth login. So somebody has a GitHub account. They just come to this page. They click on login. The GitHub OAuth pop-up opens up. It's like, are you sure you want to sign in with this particular app? And give them your, user ID. Well, the user says yes. And now the app knows that this is a certain user who has that certain GitHub account, right? So we are kind of outsourcing the authentication mechanism to GitHub, which is fine for our use case. We don't want to be having this whole series be about user authentication management and passwords and, password reset emails and sign up flows and all that. You're not doing any of that, right? So we're going to start with the login page. User clicks this button and logs in, all right? The next page is going to be a homepage, kind of homepage for this experience where they can see all of their messages, kind of like Gmail, right? So you log into Gmail, the first page you're greeted with is your inbox, and then all of the messages that belong to that inbox folder, right? So I'm going to have this folder sidebar over here, which are all the folder that the user has. Folders and labels are kind of interchangeable in an app like Gmail. You can have an email tagged with multiple labels, and it kind of shows up in all those different folders. Whereas in a traditional sense, a message can go to just one folder, right? You don't really have a message assigned to multiple labels. I'm debating if I should do the folder or the label approach. I'm going to leave it open for now, and maybe we can build it for accommodating the label mechanism where a single message can belong to multiple labels, but still have a folder mechanism so that we can scale later with functionality if we need it. Right? When you're doing database design, for example, you don't want to design it to be restrictive to using folders, and later if we change our mind and say, hey, we want labels, then we're in trouble, right? We have to change our database schema, so we don't want to do that. So we can probably design for this kind of flexibility, this many-to-many relationship between labels and messages, and still have the folder paradigm in the UI, and we can change it to later if needed. So that's going to be on the left-hand side. On the right-hand side, we have the messages itself, right? So there's going to be a list of messages that this user has, and they can click on a message to view the message details page. Okay, that's going to be the next UI. So the message details page is going to contain that same folder list on the left-hand side, and then the details of the message itself, right? So who's the from, who's the to, the subject, the body of the message, and then you have a bunch of buttons. It says reply, one more which says reply all, maybe some controls for moving the message to different labels / folders. Like if the message is in inbox, move it to maybe an important folder. So controls for moving things, and then a way to go back. Another thing which would be interesting is to have a count of unread messages. Okay, so here, let's say it says, okay, you have 10 unread messages. You have 500 messages here, right? So you have some kind of a counter which indicates how many messages are yet to be read. And when you click this, a message and then open a message, that counter needs to appropriately reduce, and somebody sends a message, this counter needs to increase. So kind of having a counter would be a cool feature to have there as well. So plan to do that. So this is the message view page itself where they can view a message. Now this is for the reading part of it. Now how about writing? Well, you need a compose button, of course. So we're going to have I'm going to stick a compose button at the top of the folders page. Now, somebody can write a message, right? So you click on compose, and now what you have is a message editing window. All right. I'm still going to have the folders list here. It's going to be consistent. It's going to show up in all the pages. I'm going to create the section here with a text box for two. I'm thinking it can be a comma-separated list of names, right? Comma-separated list of GitHub IDs, right? You know a GitHub ID of a person, you want to send them a message. You give the IDs here separated by commas, give a subject, type in the body, and then press send, and it's going to go away, all right? What it's going to do then is, let's say you have a bunch of GitHub IDs that you've specified in the two. It's going to go put this message into the inbox of all those users, and it's going to increment the counter for all those folders, the inbox for all those folders. And it's going to put this message into the send items folder for the person who is sending this message. It's going to do all of that stuff for the compose action. Now, when the user is viewing a message, right? So let's say they're over here. They're seeing a message and they click on reply. They click on reply all. It's going to take them to this compose page where they can type a message. The only difference is going to be if they're doing a reply or a reply all, the to box is going to be filled with the people who are involved in that email, right? The sender or the other person in that email, they're going to be involved in the to. And possibly the subject line is going to have a reply, RE : and then the subject, right? It's common among all messaging applications and even Gmail and other related email applications. So that's going to be the way people can go from like viewing a message to composing a message, all right? So these are the views that we're going to build, all right? Starting with the login page, the email/message listing page, the message view page with the ability to reply or reply all, and folder management. And then finally, you have the compose page where you can actually type out a message and press send. All right. So this is like the rough user experience that we're going to build. Now, what's going to be the tech stack for this? If you're a Java Brains viewer, this should come as no surprise that I'm going to choose Spring Boot for this. Spring Boot is my favorite way of building backend applications. And that's what I'm going to use for this application as well. All right. So the tech stack is going to be Spring Boot for the application tier, right? The application layer is going to be Spring Boot is going to be sitting on a server somewhere, and it's going to expose these URLs that users are going to hit, right? Now, this is the backend tier. Now, there is also a question about the frontend, right? Do we want to build a frontend using some kind of a JavaScript framework like Angular, React, or do we want to use some basic thing like Thymeleaf, a templating language? The views that we have over here don't really warrant a full-blown JavaScript application. And also, I want to focus this on building a scalable backend application. Again, similar to our previous series, we are going to be focusing on the backend and not on the front end for this series, right? So if you're interested in front end, hold on. There's another series which is going to come soon, hopefully in the future. But for this series, I'm not going to do a React or Angular or Vue or any of that stuff, right? So it's basically going to be Thymeleaf templating for the view itself, for viewing the web pages. The security part for it is going to be handled by Spring Security. All right. Now, the question is about the data, right? If you've seen my previous series, you should know that for scalable data and highly available data, my go-to choice is Apache Cassandra, right? I'm going to choose that for this application as well, right? Because the tricky thing here for scalability and availability is the state management, right? The state where the data exists. Because we think of an app like this. the application server, the application tier is essentially stateless. It is not holding on to data. It's not holding on to state. Sometimes there would be a need to hold on to state in case of sessions, like somebody is logged in, the application server has to remember that that person is logged in, right? But with OAuth and using GitHub authentication, the application server doesn't even need to do that. It's essentially stateless. You can have the server serving this user and bring up a new server, and the same user is going to talk to that server, and it's going to be smooth, right? There's no loss in having switched that server, which makes it really easy, right? Since there's no state on the server, I can spin up like 5 of these or 10 of these or how many ever of these that I need, put them behind a load balancer, and now I have a scalable application server tier, right? Well, the problem is with the data, right? How do you get scalable and highly available data tier? If you have a relational database, there's only so much that it can scale. There's only so much load that it can handle, after which it's going to be like, yeah, this is getting slow. My joins are getting slow because my tables are big. There is some point where the relational database stops scaling. Also, typically relational databases have this one server instance, which means that if that server were to go down, well, your application is down. Now, how do you handle availability when you have just one server that is doing all the work for you, and you hope that that server is up and running all the time? If something were to go wrong, well, you're in trouble. So this is where the choice of Apache Cassandra makes a lot of sense when you're thinking about this highly available application that you want to build. Apache Cassandra is a distributed database. So you have multiple nodes, and a single data element is not going to be on just one node or one server like the relational database case, right? I know there are distributed relational databases, but that's a whole another issue and comes with a whole set of problems there as well. So with Cassandra, you have multiple nodes that kind of distribute your data, and it also replicates your data, right? You can have Cassandra replicate. So have a write in one node, and that node were to go down, was not a problem because it would have replicated that write of data to some other node, right? So you have multiple replication options that you can choose to make it highly available, right? So this is the approach that we're going to use, and this is the high-level tech stack. There's not a lot of prerequisites for this thing because you would need JDK installed on your machine because you're going to be coding Java. But everything else, I'm going to walk you through how you can set this up. Especially Apache Cassandra can be a pain to set up locally. And like, how do you set up a distributed database locally? Well, the good news is you don't have to do that. I'm going to be showing you how to get a hosted Cassandra instance for following along with this Code With Me series. There's a link in the description which allows you to set up a free account and DataStax. They have a hosted Apache Cassandra service called AstraDB. You just set up a free account and you get a pretty generous free tier. There's a lot of stuff you can do, and you don't even need to provide your credit card, right? So you get a lot of mileage from their free tier, and you can certainly follow along this Code With Me series by just creating an account there and setting up a hosted distributed Apache Cassandra instance. And that's going to be truly distributed. And it's not like, run one Cassandra node on your local machine, right? So you truly replicate the distributed database instance. And go click on the link in the description to set up your account, and make sure you have JDK installed. But apart from that, we should be good to go. Before we go to the next video and start building, I'm going to draw this high-level architecture diagram. It's a very simple architecture diagram. There's not a lot going on over here. So you have basically you have Cassandra as a database node over here, which is going to be managing our data. So this is going to be a distributed database. And this is the part where you don't need to set up. You just get that free account on DataStax and you're good to go. And now the application tier is a Spring Boot application, right? And then you have your user sitting here. And this is going to respond with HTML generated by Thymeleaf. And there is also a Spring security, which is talking to GitHub for authentication, right? Nothing too fancy, very simple stuff, but this should be enough for us to build this highly scalable, highly available messaging application. If this is enough, why choose more, right? Simple architecture, which is going to give us the goals that we need. It's all we're going to use. and not overcomplicate it anymore. As far as scalability is concerned, we know that this guy scales, right? We know that Apache Cassandra scales. How about scaling this guy? Well, we can have multiple of those and stick them behind a load balancer here. Put a load balancer, which is going to send the user's request to one of those Spring Boot nodes that we have. And again, since we don't have a stateful application server nodes, these are essentially stateless. I can create as many of them as I need, and it is going to get the job done just fine. So this is the high-level architecture. In the next video, we're going to be looking at database schema design. A big part of building an application with something like Apache Cassandra is you have to be very mindful about what the schema design is going to be, right? Typically, in a relational database application, you focus on the data first, and then you build the application afterwards. But when you're building an application using Cassandra, it is really the other way around. You focus on your application, what are the needs of the application, and then you build your schema to support that application. And that's the best way you can make sure that your schema helps you in building a scalable application and not gets in the way, all right? So in the next video, let's get into schema design with Apache Cassandra.